Are we live? Let's see. Let's try that again. Are we live? It's, okay. I think we are live. Last name. 1 minute. Check the account to follow. Everyone can chat. Start immediately. Trying to set things up real quick. I'm using a different broadcasting platform today, so I will just do my best to make this work. All right. So let me see. Are we live on? Okay. 1 minute. 1 minute. He says we're live on X on YouTube. Just confirm that, and also check the audio feedback. Right. So let me do. Let me do that right now. Okay. Okay. Everything is good. So I think we're ready to broadcast now. It's a long. It's long. It's gonna be quite a long one. And okay, it's like we're live. Yo, GM everyone. GM. It's been like forever, right? Yeah. So this is the Anchor founder, and today we'll be doing be covering migration tips and not. I don't think it's breaking changes, but mostly migration tips from the Light SVM 0.11 release. If you know what Light SVM is, if you don't know what Light SVM is, let me just do a quick intro of what Light SVM is before we get started. So Light SVM is, let me just read from the books, right? Light SVM is a fast and lightweight library for testing Solana programs, right? So it helps you test your Solana programs, and it has Rust client and TypeScript client, so far as I know. Yes, so this is one Rust example. So it is LightSVM is like a light, I keep saying light, virtual machine that helps you make testing Solana programs faster, so you can simulate most of the things that you can do in a regular virtual machine. See, yeah, there are a lot of cool stuff you can do like SVM also. You could test out time traveling if your program requires time travel. You could go to the future, and let's say after 10 days your users should be able to unstake their tokens, right? You can travel into the future in Light SVM to test all of those. Is great for unit testing actually, so just put it at that. And if you've written, let me show you what Light SVM looks like inside tests. 1 minute. It's 5. Let me bring up one code quickly. Yeah. So yeah, actually, it's actually yeah. You have your Rust test, and so this is a key pair. This is a Solana key pair. You create Solana key pair. You can get the pub key of that key pair. You can airdrop tokens to an address. You can build a transfer instruction. You can, this is a transaction, can build a new transaction, can send it to the network, right? So it is like a full virtual machine, Solana virtual machine, but for writing for unit tests. So you need to, the most important part of writing a smart contract is testing a program actually. So what's this of writing a program that you can test? And you don't test it to validate that it actually works in the constraint that you actually want it to write. So yes, so that's what Light SVM is about. I want to cover the major release notes. So this one is release 0.11.0, and what that's about is this is the release notes. So adds a feature gate account support, adds custom syscore registration. There are a couple of things there. Aligns rent check for assertion with Solana behavior, updates rent exempt. Load the P token binary instead of the SPL token. This one we're going to test actually. I'm actually excited about this one. So you can test your Solana programs using the P token that would be activated on mainnet soon. It's already activated on DevNet, I think, or on testnet. And so, how do you actually activate a feature in litesvm? We're going to go over that. So, majorly everything, most of the things that are here, for the most parts, most of the things that are here. So, let's get started. I will test in a simple Solana. This is a basic program. It's like an escrow, but not an escrow with some bells and whistles. It's written in Pinocchio. It's just Pinocchio is it's like a bare metal Solana framework for writing. Not a framework actually. It's an SDK for writing Solana programs that are very efficient, lightweight, cheaper. So all the good stuff, right? But it just comes with a little more responsibility for how you the things that Anchor don't make you think about. Pinocchio definitely needs you to think about those things. So this is basically it's like a fundraising program. That's what it is. It's basically a fundraising program. And the instructions we're going to test is we just want to write tests for making our program work. Right. So this is a program. This is the entry point to the program, right? So we have the program instruction right here, entry point, and returns the program result. So every instruction has three major things on the surface level. The program ID that instruction is communicating with, the accounts that are required for that instruction, and what data are you passing to for that instruction to work, right? If the instruction is extra instruction data, all those instructions, all those data, you pass it here also. So those are the three basic things on the surface level. And we're just getting, so we expect that for this instruction, for the instruction data, the first byte of the instruction would be the discriminator. I'm just basically explaining how Pinocchio entry point looks like. So we are expecting that the first byte of the instruction is the discriminator, and every other thing that comes after it is meaningful data that we can work with. So we are splitting it off. We're splitting the first. We're popping it off. So split first to get the discriminator, and every other thing behind it is data, right? Yes. So, and we are doing a simple if if the discriminator is index 0, call the initialize instruction. If it is index 1, call this instruction. You could simply just do match. You could just do match discriminator, and you just do, because it's a byte, right? It's a U8. You just do if it's 0, call instructions. This bro, yeah. You could literally do this, right? But what we're doing is for simplicity and to make our code readable actually. So every other thing fails, right? So that's, we could do this, but to make it readable, let's just clean up our code and all right, good code actually. So that's why we created this fundraiser instruction struct here. Check inside the mod. We have an enum that is fundraiser instruction, contains different instruction for this fundraiser program. The initialize is at index 0, deposit is 1, cancel make. So yeah, basically all of that. So that's what the entry point looks like. I'm just trying to break everything down to the easiest part that you can actually work with it before we get into writing the test. So this is basically what our program looks like. So let's get into the first one, the process initialization instruction. So once we initialize the contract, the program, what's the first state that needs to be set before anybody else make this instruction? And now that anchor is gone, you need to, now you are thinking of all the edge cases for your instruction to work out. Before I start writing this, I always like to start off with a fresh mind map of what the instruction will look like. Let me check if there's the timeline. Okay, timeline for this instruction. Let me check the first. Is it this one? This one? I don't know. I think that was so far back. And it's not tracking anything behind this. Okay, okay. So let me just cancel it. So what I did then was I wrote out all these comments first. So all the checks. I checked that the maker is signer, cast data type. I wrote out all the checks before I started writing any code. So you need to do a mind map of what the flow of your instruction entry points is going to be like. Check that the font data is empty before I started writing any code actually. So after that's done, the major part I would need to worry about now is what will an instruction look like. So like I said previously, for the instruction entry point, we're taking the program ID, then the accounts and the data. But since we already know the program ID is this program that we're working with, then for the instruction, we only need to pass the accounts for this particular instruction and the data for this instruction. So that's what we're doing here inside initialize, check initialize, or passing in the accounts, which is accounts view. This is a new update for Pinocchio. Previously, you would have seen account info if you are familiar with account info in our core. It's now called account view Pinocchio. So it's just an array of account view, so all the accounts, and the data is also a big array of bytes. And for the accounts that we need for this instruction, we're hard coding the account that we actually need for this